the pressure of a gas will cause a force to push outwards against the container it is in. Remember that a gas consists of particles that move randomly at high speed, making them spread out in a container. This means that the particles collide with the walls of the container, and when we consider the impact of all of these, they create an outward force, or pressure. Now let's suppose we wanted to compress this gas. In other words, make the container smaller by moving this press down. What would we have to do to achieve this? Well, in order to compress the gas, we have to do work against this force. Remember that work is when forces cause a change in energy, either because a force is making an object move, or an object is trying to move against an opposing force. So in this case, to compress the gas, we would be trying to move the press downwards. But this means we're trying to push against the pressure from the gas. In other words, we're trying to move the press against the outward force from the gas. And so, we have to do work against it. This causes energy to be transferred to the internal energy of the gas. We can just explain this through the work that's had to have been done during the compression, but we can actually explain this in more detail by thinking about what happens to the gas particles. So when we compress the gas by moving the press down, it will push against the particles. This will cause the particles to gain speed as they bounce off this. You can think of it like the difference between a ball bouncing off a wall or being hit by a tennis racket. So since moving the press causes the particles to speed up, they have gained kinetic energy, or Ke for short. Then remember that increasing the kinetic energy will increase the internal energy of the gas. Also remember that the temperature of the gas is a measure of the kinetic energy of its molecules. So if this kinetic energy has increased, then the temperature has also increased. For your exams, you need to be able to explain this change in internal energy and temperature, both in terms of the work done compressing the gas and the effect moving the walls of the container has on the molecules. But what's a common scenario where we'd notice this change in temperature? When pumping up a bicycle with a bicycle pump, we notice the end of the pump becomes hot afterwards. Now this is a very popular example used in exams. So when we pump up the tyre quickly, we are doing work quickly against the pressure of the air in the tyre. This means the end of the pump heats up and becomes hot to touch. This is because the temperature of the air in the pump increases due to the work done. The work has caused energy to be transferred to the internal energy of the air in the tyre, making the air molecules move faster and increase in temperature. On the other hand, if we were to pump up the tyre slowly, then we probably wouldn't notice this change in temperature. There is still work being done, but we would be giving the pump time to cool down.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!